This is the Amp Hour Podcast, recorded July 27th, 2016, episode 308, an interview with Stefan Dzisiewski-Smith. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Stefan Dzisiewski-Smith of Bear Conductive and various other projects previously.
Oh yeah, I never would have gotten that right. I wouldn't have gotten even close with your name.
It's tough. It's going to be something when you're driving to and from the nursery that my mum would drop me off at. My mum was a teacher, or was up until recently, and she would actually teach me in the car how to spell and say my surname. Because I had to kind of take ownership of it from a very early age. It's been going all my life, and I imagine it will continue to do so.
Did you do one of those things where like a teacher would start pronouncing your name and you'd be like, yeah, I know what you're talking about. It's me.
I think it's interesting. So my mum was born on a refugee camp in in Southwest. So her mum joined the British Army as a nurse. It's actually an incredible story that maybe is not electronics related, but she joined the British Army as a nurse, having escaped from a work camp in Poland, and drove actually through some pretty terrible war-torn stuff in a stolen laundry truck, of all things, because she could speak Russian. They lived near the north border with two of her boys, and managed to end up in Egypt, where she joined the British Army as a nurse. The details are somewhat lost on me. How you get from the northern border between Poland and Russia with two boys and a laundry truck.
That's a long time in a laundry truck for sure. Yeah.
I imagine that there's lots of details that I am not picking up on, and no doubt lots of help from other people on the way. But so she joined the army as a nurse and was resettled. So my mother being the daughter of a refugee and being brought up initially speaking Polish, and then when they realised that they weren't going to be going back to Poland after the Second World War and that they were going to settle in the UK, my mum is very defensive of her heritage. So when I was really young, I was very, very, she taught me, and I would get very prissy if people spelt it wrong at all, and I would really defend it in kind of her way. And I think, there was a point, I think, when I hit secondary school, about 11 or 12, when I realised that if I wanted to have a few friends, I probably needed to lighten up a little bit and let people come to me with it, right? Most people get to a point where they're like, it's important to spell your name right. But it's not good to go in all guns blazing initially, I don't think.
Right. And it's interesting now, too, with with internet stuff, right? I mean, I'm guessing you're the only one with that name probably in the world. Maybe that's a pretty solid guess.
Yeah, certainly with the double-barreled. And it turns out that, in fact, most of the Dzisiewskis and the Dzisiewskas, so in Poland, your name takes gender. So my sister is Dzisiewska-Smith, I'm Dzisiewski-Smith.
Oh, interesting.
But all of the Dzisiewskis and Dzisiewskas that are on the internet are actually related to me, or I am related to them. Mm-hmm. So... it is quite interesting, and that level of connectivity, although there's still big gaps. So, like I say, I don't know all that much about how Babcia, my grandmother, Babcia Zena, got to the UK. The details are with my mum, really, and it's all kind of secondhand. There's a lot of records that aren't linked in and available. So although the internet, it's brilliant at linking information that wants to be linked, right? But you can't grep dead trees. So there's a lot of stuff hidden in books, no doubt, that has more accurate details on this kind of thing.
Until the OCR gets a little bit better and the searching can happen through that.
Yes, yeah. And I think also the effort is there for people to put time and effort into documenting, archiving, and sort of indexing these things in a sensible way. Maybe Google, maybe that's part of their big plan. I don't know. Yeah.
Well, speaking of background stories, we should mention how you and I met. We met in Belgrade at the Resonate, right?
Sort of the back end of... You were there for Hackaday Europe, where Mike Harrison, who's a mutual friend, he had been giving a talk, and you'd been there, and so had Sophie Kravitz and Mike from Hackaday, a whole bunch of people. I think we arrived on the first day, I can't remember, the Thursday, whenever day it was. And Mike was like, "Oh, you should come to this meal," and we all got in. We were like, "Yeah, we got nowhere, no plans on the first night." So we turned up there, and it was just everybody was there, and it was suitably hectic, as Resonate is every year. But it was great to sort of meet you and a bunch of other people. You all looked like you'd had a pretty big. You'd already been in Belgrade for a while. You looked like you were well settled.
A little bit of partying, a little bit of this, a little bit of that, yeah.
Well,
and you guys brought like an entire I was really surprised at that event. So I knew Mike would be there, and he mentioned there was a bunch of people from London, but like it seemed like a big part of kind of the art, technology, design community, though, like kind of just transplanted to Belgrade for that week. So yeah. What's your role like in that group? How did you get into that whole thing?
So if we go back to, I studied electronics at Imperial College, and when I got done with Imperial College, I realised that I didn't really want to go straight into industry. I'd been doing some work for a high voltage power supply design company in my free time, sort of in my breaks, my holidays. Realised I didn't want to get stuck into that straight away. Answered a random email from our department administrator saying there's somebody at the Royal College of Art who wants to make a thermochromic book cover and animate it. And I was like, I remember really distinctly getting up. It was like the middle of the day. I was really hungover. I'd been out. I saw this email and just went, yeah, why not? So I got involved in this mad project, and with I remember it to this day, a little PIC 16F87, a whole bunch of assembler code, because I don't think there were any free C compilers that I could get working or whatever at that time. Right. So I programmed this kind of scrolling message display system that used 5 ohm 10 watt flag heaters inside a book. I mean, the whole thing was a nightmare. It had a linear power regulator as well, because
so have you ever been electrified by a book before?
It was, I mean, I had like I say, I had a linear power regulator in there. So the linear regulator was getting hotter than anything else, because I didn't even think, and I just didn't have time or the experience. I was still recovering from all the knowledge going in, and there hadn't been time for it to settle and turn into experience. And so I did this thing anyway. The guy I did the project with said, you should apply to the Royal College of Art. They have this course called Industrial Design Engineering, and everybody goes. You get journalists, econometrists, designers, people involved in activism, all these kinds of weird, disparate people come together at this course. And I know that they'd love to have an electronic engineer. And I thought, well, I might as well apply. And then I had to do something called a portfolio. And I was like, well, what do you mean a portfolio? They were like, all the work presented beautifully. And I was like, I haven't really done any. So I made a load of crap up, learned to use Illustrator. It looks terrible. I actually keep it. I may even have the original file. I'll see if I can share it at some point with you. I mean, it's absolutely awful. It was just loads of lies and ideas about products that I'd never made. And I think some really terrible photographs of a Nixie clock that I was busy making the power supply for. And maybe the very first PCB I ever made, which was when I was maybe 13, 14 at school. They had a PCB etching set up, and we made PCBs. Nice. And so I somehow got in, and then I was like, I remember at the time I had this girlfriend from the States. She was there when the letter came, and she picked up the letter from the front door, and she was like, oh, I'm kind of so sorry, because it was a small letter. And when she got her acceptance letter, it was a really big letter.
That's right.
So I actually kind of ignored it for a couple of days. And then I opened it. I was like, holy crap, I've got in, but we've got a really big problem. I've got no money. And my parents, certainly, they've been very generous in funding one master's degree, because I did an undergraduate master's straight through at Imperial, which was 4 years. There was no way they were going to fund it. So I had to get funding for that. This is a very long-winded story, but I ended up getting funding and having to go to the RCA. And at that point, I was like, oh, my law. I was actually sick on my first day on the way, because I was like, I am going to be bottom of this class. I can't draw. And lots of people say they can't draw. It's like I have the drawing equivalent of dyslexia, and that's not meant to be in any way offensive to people with dyslexia, but I really struggle to express my ideas visually. Very hard for me to take an idea in my head and express it. And I work really hard on drawing. I try and draw at least once a day to improve that, but I'm still terrible. Drawing's a lot about practice, and it has improved, but like I have to really work to communicate, right? Because I work with lots of visual people, and if we don't have a kind of lingua franca to exchange ideas in, then we're not going to do the best stuff. So I was petrified, and I nearly quit the course. Like, I don't know how many times people listening to this who know me will remember the day that I stormed out of the place and went to get... I just walked straight across Hyde Park, across from where the Royal College of Art is, and ended up in Edgware Road eating a little cup of kind of sweet corn with flavouring on it, just sat really sad on my own. And I'm just really wondering how I'd ended up on Edgware Road eating sweet corn and feeling upset with the world. But I slowly came to realise that there was a lot that I could learn there, and there was a lot I could give, and there was a lot that I just had to, work really hard.
Yeah. So tell me more about that experience. So you apply to this program, but is the expectation that you basically go through artistic training like this would be like the equivalent of like an MFA type program in the States, like Masters of Fine Arts type of thing, or
sort of? So I mean, it's at the Royal College of Art, which is a postgraduate only institution, but the degree when I took it was, so they are all masters. The degree when I took it was a master's in industrial design engineering. I think it's now referred to as innovation design engineering. But the idea was that you could come from any background. As I mentioned, there are lots of different people from disparate backgrounds, and that you would come together and work on design-oriented projects. There is some technical guidance there. So there were drawing classes, and there were classes on how to do 3D modeling and additive and subtractive rapid prototyping processes, design thinking. There was a lot of peer-to-peer learning within the group. So there was a lot of group work as well. So let's say the very first project we did, we had to create actually the only purely artistic thing that we did while we were there, which was an art intervention within London. And so we ended up making a whole load of origami birds out of cartridge paper and sticking them up in a tunnel that goes underneath the railway that's used by buses in Vauxhall Station near Oval Cricket Ground in London to brighten up the tunnel. So we had this idea that London's got lots of lovely, beautiful places, but it's also got some dark places, and we wanted to brighten one of them up. But the whole process of getting to that concept and justifying it, I mean, going through critiques, in the first week, we had to stand up and say what our idea was, and our original idea was something quite different. And I remember to this day, it was like the end of the first Friday. I was exhausted emotionally, exhausted kind of socially, and they told us that our idea was completely shit and to go away. And everybody who'd been through design sort of school was like, oh, well, it's the first project and it's early on. Of course, you're going to have negative feedback. And I was just destroyed. I was like, it's a really nice idea. What's their fucking problem? Like, why do they have to be so mean? And that was the start of me taking stuff way too personally for quite a while on the course. But you build shots, and I think actually having the ability to take criticism, which I think people who know me will still say I'm not the best person at taking criticism, and I do take things to heart, but I at least now know not to shout back, to listen about it, get on my bike, go and ride all the pain out, and then start to deal with where the truth is in what they're saying, and whether I think I can improve or iterate on something. But anyway, so
that's interesting too, because I mean surely you had to do the same kind of thing for like design reviews for schematics and the technical stuff in the past, but somehow it feels like that's more of a logical thing. It's like, oh, I was wrong here, versus, oh, well, this is the thing, this idea I came up with, and now people say that's a bad idea, right? It feels more personal, or sounds more personal, at least to me. I think
there's an element of that. I think there's also an element of, within engineering, the brief tends to be tighter earlier, and it tends to be a more linear path. I've realised that there is always problem solving, there are always things to iterate, and sometimes you have to rip up and you learn completely new ways of doing things. But within the engineering environment, when I was working in this high voltage place, I was working with some brilliant, really talented and very friendly engineers who took me under their wing. I was developing test equipment for their designs largely, and they knew what they wanted, and in a way they wanted me to be kind of an extension of their arm so that they could do more work. but also to use that to inspire me to think about techniques and to take that on board and then synthesize some of my own ideas from it. So it was quite friendly. There was a lot of scope for failure, and there was a lot of scope for small innovation. But the difference with...
There was room for failure with high voltage, because I that's not my experience.
Well, there was room for failure in the areas I was working with. We did have a few mishaps. We did once have the floor set on fire. I had some people call up to my office and say the floor's on fire because arcs had just found their way down. We did all our testing in large cages. I mean, there are a lot of, when I said there's a lot of acceptance of failure, there are also a lot of safeguards. I said. Okay, the floor's on fire. Have you hit the emergency stop? Not yet. Why are you on the phone to me? Go to the emergency stop. Put the phone down. Right. Stop buggering around.
Big red button. Yeah.
Yeah, exactly. And that was an interesting one. That was where you start to find out about tracking. Really about tracking. We had something like an 180 kV, 125, 128 milliamp output, power supply for an X-ray tube. And we were testing it on a resistive load, which is sort of a 5-6 foot high perspex triangular prism with resistors arranged going down it. And what had happened is they needed to do an offload test, but they'd left so the way you normally do that is you leave the connection at the top of the resistive load and you disconnect the ground return at the bottom, right? So you set up 180 kV of field across the 5 feet. The problem was that the previous test that they'd done was a half-load test where you look at the current limit and protection circuit. So you run it into half the expected load and ramp up the current until it clamps, right? And that had passed, right. But then they pulled out the ground return at the bottom. Now you only had half the distance of the stack, and then set the output to full kVs, and the current just went, let's see what we can do here, and sort of snaked its way round. And found the floor and made a sizable burn mark, which I have to say was my fault for not being very explicit about saying and kind of the order of operations in the test. It was a semi-automated test as well, so this was actually running. We were actually controlling this through a PC, so we did add some safeguards subsequently to that.
That's good. So. Well, I want to get back to the design thing real quick, but in a second. But this high voltage place. So what was it was like a test lab, or what was it?
So it was a company. I'm not going to mention the name just in case stories that I say are considered less than positive. I think it was a brilliant place to work, but obviously I've just told you there about a mistake that I made. I think we dealt with it really well, but I don't know how they would feel about me telling the story. I hope very positive. They're a lovely bunch of people, but they manufacture and develop high voltage power supplies for a number of different applications, including a number of analytical X-ray machines, some medical X-ray, and also things like power feed for both shipborne and landborne power feed for fibre optic telecommunications. So it's an amazing place to get as your first place to work. I mean, everybody else is working on, stuff at normal voltages, and I'm trying to remember that, 10 kV per inch is a good tracking distance in air, and you can do 10 kV per millimetre inside rubber, but then you've got to think about, the boundaries between dissimilar materials. And we had a plasma etching machine in the potting environment to plasma etch the surfaces to prime them for good keying to the rubber. All sorts of things like this that I would never have experienced in any other way,
Oh, so like the plasma pitted out the surface so that when the next layer bonds to it, it has more surface area kind of thing, or how does that work?
Exactly, yeah. So you deliberately erode the top area. It's partially a cleaning thing, and then also, I think, as I understand it, there's sort of a micro pitting that then allows the rubber to key really well, because what you don't want inside a potted rubber stack on a high voltage power supply is for there to be dark discharge or tracking within that starts to break down the rubber, because then the rubber starts to carbonize and then it starts to conduct better, and then eventually you end up with a slow and eventually catastrophic breakdown that it's also then really difficult to repair without digging out the rubber. I mean, I definitely spent some of my time digging out rubber. That was a boring job. And the rubber's like this really dull grey as well. So There's not even any fun to it. Although we used to make, we always had spare rubber over, and we'd make like rubber balls or rubber hands or various jigs for bits and pieces. There was always kind of a competition to see who could pour rubber into what interesting mold. That was towards the extent of the fun you could have, though. I mean, you did have to play sensible.
Right, that makes sense. No, that's cool. And is it layered because of like air? You need to get air through it and that kind of thing, because you couldn't just pour it all the way through.
No, well, you pour it up to it. So you normally pour it over the high voltage end of the stack. If you've got a board with low voltage at one end, so you'll have the forward part of the control loop, and then you'll have the stack, and then you'll normally have a high voltage, just a high impedance, well-matched resistive network divider, and then that will go and feed that to the low voltage end and into the feedback loop. I mean, obviously the topology depends on which parts need to be isolated from where and whether it's positive or negative if you've got a grounded or floating filament for an X-ray in there as well. But you tend to pot just the high voltage side, and you leave the low voltage side unpotted, because you don't want to pot anything you don't need to, and obviously you want to be able to get at things like trim resistors and things like that.
Oh yeah, that makes sense. Oh, well, that is really that's that is a new topic for the amp hour, I think. I think we don't really talk about high voltage very much because, well, personally, it scares the bejesus out of me. So, yeah.
I got a few healthy shocks. I used to budget for one a year. I got some big ones. Yeah, I definitely got one where somebody had managed to disconnect the protective earth on the casing of a unit that basically floated up. I mean, it was another 180 kV, sort of a 4 kilowatt unit, which is quite frightening. As I touched it to switch it off, because we could hear ticking. I should have hit the emergency stop, but it was late and I wasn't thinking. And as I touched the case, I'm pretty sure it was through, I guess, the X caps in the input mains filter. The return current had found its way back through there. So I got sort of probably about 5 kV. It would have limited. But yeah, about 5 kV through some caps. Very buzzy. I remember it now. I can visualize it. It makes very clear memories. But there's lots of other fun things, looking for arc discharge in high voltage setups, either listening for it with really long acrylic tubes, because obviously you don't want to get anywhere near the unit. So using long acrylic tubes to try and listen for where the ticking's coming, or putting your lab coat over your head and looking in a very darkened room to try and observe UV where ozonation was taking place. That's another good technique. Yeah. And obviously thermal cameras as well. So you can do quite a lot of circuit debugging using thermal cameras without having to touch anything. And these are all good techniques that actually I've taken on in my career and used elsewhere for different reasons. So yeah, I owe an awful lot to everybody there, really.
Yeah, no, that's that. I mean, that is usually and the important thing is that, you were okay. And I think the interesting thing is like what you said about it was late at night too. I think probably one of the biggest safety protocols is like, you know what? Everybody goes home after 8 hours just because you get tired, you start making mistakes.
It wasn't late at night. Sorry, I should clarify that. It was late for me by which I mean 5 at the end of the day, and I'd probably been partying the night before. So I brought some of that on myself. But the safety precautions that were taken there were fantastic. I mean, everything got written up, all incidents, everything was taken exceptionally seriously, because we were working. I mean, we had X-ray tubes as well in lead-lined boxes that we were building, and they weren't always 100% first time. I still remember one being, equivalent, I guess, of bringing up a board, but bringing up an X-ray tube in a kind of these kind of coffins. I mean, they look like, without wanting to sound horribly morbid, a kind of coffin for a child lined with roofing lead that was then folded up into this wooden coffin, sealed at the corners with a big heavy-duty soldering iron, and then a lid on it. And then you've got the tube, which is, I guess, the ones we were using, again, about the size of a child. I don't know why that's my frame of reference, but they really were. And I guess they were delicate, so we treated them a bit like... Well, we treated them delicately. But then you've got normally a water cooling system in there, and possibly also a vacuum system to maintain the vacuum inside the tube. Some of them were vacuum caps, so you would vacuum down the tube and then cap it off. Some of them were on a continuous vacuum pump. And then you've got water cooling to stop the filament melting and to stop the beryllium tube exploding. Sorry, the beryllium window on the end of the tube sort of or exploding or doing anything like that. And I remember...
So the lead-lined box, though, was just to make sure that if there were any emissions, it just absorbed those? Is that the idea?
There absolutely would be emissions. We ran them live. We dumped significant load into that box. The thing is that X-ray tubes are very difficult to simulate. So we did have some tube simulators that simulated by taking the low-voltage control end of the circuitry and feeding them through and trying to emulate, because what you've got is you've got a filament. You're running the filament in a closed control loop saying... That allows you to control the current through the filament. Then you set up the voltage using your voltage feedback network, right, through the resistive divider. But then you set the emission current from the tube by adjusting the filament current, right? The voltage and the current are independent from one another, relatively speaking. But you're
it's like a valve, right? Like a vacuum, like any other vacuum tube, right?
Yeah, like it's just a hot filament valve, but the target is is something different, normally tungsten. And then there's other bits and pieces, things like microfocus in there as well, electrostatic deflection, and all sorts of crazy bits and pieces. I mean, the people who worked there were phenomenal, absolutely phenomenal at what they did, and I don't claim to understand even 1/10 of what they were doing, but I got to see a lot of it and to watch some really professional people make what could have been a very dangerous environment exceptionally safe. But yeah, we had a day that one of those tubes we were going, it would, was ready, the box was ready to be checked, and the chap who was doing the sign-off was going round, so you set high kV and low milliamps initially, so you've got very good penetration, very few particles going through, X-ray photons, and just going round with a scintillation counter around all the edges, and one of the edges hadn't been soldered, it'd just been overlooked, and the scintillation counter went crazy. The emergency stop was hit very quickly, and we all looked very worried. But the procedure was in place to be very sensitive at a very low level. We had, dosimetry badges both in the area and on every person. Yeah. And we were all quite interested in what might come back at the end of the month. But it was barely a blip. We experienced far less radiation working there than you probably would anywhere else, just because we were super tight on everything.
Right. You get more in an airplane, right?
Yeah, you do get significant amounts in an airplane. Obviously there's stories like don't take Brazil nuts or bananas into a nuclear power plant because it will set things off. But yeah, and the one that I think really gets people is people who work on scrap metal sites, finding interesting pieces of metal and picking them up and putting them in their pocket, not realising that they're obviously not an X-ray generator, but they're a radioactive substance. They've just placed it very close to their skin. There were some really horrible pictures that are X-ray, when we did X-ray training days, radiation training days, that they showed us, and that can go real bad real quick.
Yep. Yeah, I've seen some of that stuff because, not former guest, but Jeff Kaiser, who's on here all the time, he has that Geiger Counter tube project thing.
Yeah, that's the open counter, right? Is that the one?
It's not the open counter, but it's a lot of them are the same. They all use those old Russian Geiger tubes, basically. So they're interesting projects.
Yeah, they're super interesting. I mean, this kind of links back to Mike Harrison. I guess I should let's. Well, it's up to you, but we could talk about how I know Mike, because it kind of ends up. It ends up with me buying Mike an airport X-ray scanner for his YouTube channel.
So you're the one, huh?
Yeah, that was so. Mike is a fantastic chap. I sort of admired him from afar through his website when I was interested in building Nixie tubes. And then, so I finished the RCA, and I wanted to get out of London. I was completely fed up with all of the pressure. I kind of just didn't know what the heck my life was about anymore. This is very common amongst RCA graduates. It's a very intense pressure cooker of a course. And so I went back to Brighton, which is where I'm originally from. I got a house just outside, or got a flat, rented a flat just outside of this train station with some people that I just met on Gumtree, so some random people I'd never met before. And I was working at the high voltage place, and I started a darts team. And I love darts. I've got a few loves in my life. Cycling, darts, and cricket are my main interests.
Oh my God, so British.
I know. I should have a portly belly, but the cycling helps keep that at bay. But
that's good. Yeah.
Dude, I was just working. It was 8:15 till 5 every day, and we only did a half day on a Friday. And
nice.
I was in Brighton, which is a great party town, and I was playing darts and not really caring about the future, just living a very happy day-to-day life. When one of the people that I'd studied with at the Royal College of Art, who had previously, she had studied in Brighton, and then she was from London and had studied in Brighton, then come back to the Royal College of Art to do her master's. And I'd kind of done the opposite, where I'd grown up in Brighton and studied in London. And she said, Stefan, I used to work, or I've done some work at this architectural lighting design and art installation place. They're looking for an electronic engineer. I really think you should apply. And I went kind of, I don't know. I don't care. I'm hungover. I'm playing darts tomorrow. I'm doing whatever. And
I've got priorities here. Come on.
Exactly. So I was very dismissive. And then I got a phone call again saying, I really think you should apply. I think it'd be great. This is a chance to do some really creative stuff, work on everything you'd done at the Royal College of Art. And I wasn't really sure I wanted to. I wasn't sure of anything. And then I got a call from the managing director of the company saying, we'd really like you to apply. And I was like, yeah, I'll get around to it. And then I got a call saying, you're coming to just get to London. Come now, do it. So I went to see my boss.
You got the job?
Well, I did. I went to see my boss at the high voltage place and I said, look, Matthew, I'm going for an interview and I think if I get it, I'm going to take the job. And he was like, well, we never really thought you'd stay here as long as you did. We're happy with the work you do. But you're young, you should go and explore some stuff. And I was really buoyed by the kind of support from him. And I think that gave me the confidence to go and see what was what. And I got the job. And I mean, I think there was a dearth of applicants, to be absolutely honest, which is something that continues in London. There are more jobs for creative electronic engineers than there are creative electronic engineers to do them. Which is both a brilliant and a frightening position to be in terms of if you like sleep, it can be difficult sometimes.
Right. It's all feast, no famine kind of thing.
Yes, so I mean certainly that's my experience of it. Maybe I'm particularly fortunate, but that's the way it seems. But I went up and I started working there, but I went from a company with 20, 30 technical engineers and test equipment designers to just me. So we're going to take £500,000 off this city or this particular architectural installation where they're building, let's say, a huge arena like the Matthew Knight Arena in Eugene, Oregon. And they want an artwork. And what we want you to do is to work out, we'll come up with some concepts that basically are physically impossible. We'll take up a lot of time designing them. We'll spend a lot of money in fees, and then we'll give you about £5 and 2 weeks to make an artwork that we've charged $500,000 or whatever for. I mean, that's a gross exaggeration, but I suddenly had to do software. I'd never really written any vision stuff, any computer graphic stuff. I learned open frameworks. I bought numerous books on C, C++, just cracked onto sorting that out. I mean, it wasn't that long previous that I'd been writing PIC assembler code and cursing the PIC structure for having banked memory. And now here I was trying to debug network cameras over fiber optic links in a stadium with doing optical flow analysis and then driving custom LCD panels with Mike Harrison's drivers. So this is where I sort of really got to know Mike, in that they said, okay, I can't remember which project. I think it was actually the Oregon project was the first time that I was like, look, we've got to make these driver boards and I'm not really sure how to go about it. I think I might need to, find an external electronics consultancy. And they said, don't worry about it. Give this guy a call or an email. And it was like mike@whitewing.co.uk. I was like, whoa, you work with Mike Harrison. So suddenly there was a kind of fanboy moment. And I was like, oh man. So I emailed him my incredibly terrible spec for driving LCDs where I'd drawn half the circuit using XOR gates and God knows what else. And Mike was just like, yeah, we're going to use DMX. We're going to have this many per thing. What's the capacitance and the size of the panel? And I was like, I don't know. And somehow Mike's infinite patience and kindness helped me to get into discussions with the LCD company. I mean, I'd never worked with LCDs before. I'd never worked with DMX before. I'd never worked with differential. Well, I think we've done a little bit of RS485 in some of the test automation at the high voltage place, but nothing.
Well, to hear Mike talk about it, he just gets excited about the problems too. So like that's what he chases no matter what.
Exactly,
so
and I think
I'm sure that you not understanding or coming to him with a real problem is probably the best case scenario. If you would have come in with, here's how we're going to do it, that's a different thing, I think.
Yeah, and I think Mike appreciates people who listen and learn. If you're not going to pay attention, then I think he has less time for you. I think he likes people who put the effort in on their side as well, which is reasonable. And also, I think we were very lucky that the LCD shutter panels that we were using weren't something that he'd driven before, and he had a lot of the prior experience to do, say, the DMX back end, but the driver that he was going to onto it was something different, and that's how I got to know him. And I worked at this artwork place for I guess 2.5 years before really just burning myself out pretty terribly. But I learnt an incredible amount, and I made some amazing friends. Excuse me. The majority of who are the people who turned up at that dinner. So there were probably, I think we started as about 12. I think by the end of the Belgrade tour, by picking up people who, friends of friends and people that we'd worked with, there were a group of nearly 20 of us marauding around Belgrade. Yeah. But in a very genteel and loving and respectful manner.
Of course. Yes, right. Not shouting.
Well, no, I have to be very clear. British people don't have the best reputation for holidays abroad in terms of rowdiness. So
I've heard that too.
We must be
from some of the people in Belgrade.
Yeah, exactly. Well, look, I think it's very difficult, especially with the UN intervention in the Yugoslavian war. That's very recent and very real, and it's not. I think there are certainly taxi drivers there who were very open with me that they weren't impressed with the idea that British people just come there because it's cheap. And when I explained,
right, I think,
I explained that we love the city and we come back, and I mean, we definitely, unlike the last night after Holly Herndon, we ended up in this bar, having a few, liveners before we started to chill the night out, and there was a chap who got really kind of shirty with my friend Martin and started talking about the fact that I think the gist of it was that in some way Martin was responsible for the bombing of the city.
Oh my!
And it was a really tense moment. Actually, I was quite impressed. The guy's friends encouraged him that they should leave and leave us to it, which was a very pacifist way of dealing with the problem, because I don't know what we'd have done if it had got any more difficult. And there was quite a big group of us. We would have been difficult to motivate and explain to each person in the group why we now had to leave, although Martin had done nothing wrong. So, yeah, there's tension, and I think that's something that you learn to deal with when you're working or visiting other countries. There's always going to be prejudice and bad reputation and things like that, and you just have to work on being a decent person, right? And friendly and open. And
gotta respect the local culture too, like we were talking about before the show.
Exactly.
When I go to London, it's not I don't call them chips. No. I don't call them potato chips. I call them crisps.
Exactly.
I don't call them French fries. I call them chips. Like you gotta respect the local tradition.
Yeah. And when I was working in Oregon, I mean, I had a great time working in the States. We did a number of projects in the States, and the Oregon project was actually fabricated in South Boston. So I did quite a few.
Oh, really?
Yeah.
Wow.
Which is super cool. Really, really nice signage company there, who just took on the fabrication and were quite happy with the fact that it was really weird from their point of view. The kind of most interesting, the most unusual stuff they might do was a large 3-dimensional steel and aluminium baseball for a baseball ground, and suddenly they were doing a structure. It was all epoxied together. I'll have to find a link for you to share, but this thing was absolutely huge. I seem to remember something like 12 meters by 7 meters, so 21 feet by 36 feet, and it was all like epoxied together. I'd never seen so much epoxy going into something.
Buckets and buckets of epoxy.
But they knew what they were doing, exceptionally professional. I will say that. My experience of American fabricators and American workers in general is that they have much more of a can-do attitude than some British. I guess the average level of can-do attitude in the States, to me, seems to be higher in industry than my experience in the UK. I'm very lucky to have worked with some really brilliant people, but I do still work with some suppliers and subcontractors who you almost feel like you're forcing your money into their hands and encourage, right?
Yeah.
Whereas,
that's I don't think that's true. I don't think that's a regional thing. I think it's just it's more of a, when there's competition anywhere, you're going to get people that, like, you can go seek out the best ones. And then, like, in the situation you're talking about here, I would imagine if you approach a signage company who does good work and is normally doing, day in, day out, reliable work, but then you approach them with something weird and interesting like that, they're just going to double down and do awesome work on that as well.
I mean, they did fantastically. And I guess there is an element that if you are open to inquiries from people from another country who you've never heard of before asking you weird stuff, then you're probably self-selecting as slightly more open-minded and talented people. So they were absolutely brilliant to work with. I had a great time doing it, but it ended up being too much for me. I really was working something like 6.5 days a week, and that's not good for anybody. I mean, no. It was an unhealthy lifestyle. That's when you start making mistakes,
right? Like the high voltage thing.
Well, yeah, and potentially as well. I mean, I had to learn how to work at height. I remember dropping, again, one of Mike Harrison's soldering irons. I was up inside a 12-metre structure with a further sort of 5 metres drop underneath. So 17 metres, what's that? God. 51 feet. Yeah. And I dropped Mike's gas-powered soldering iron, which we shouldn't have had to be using had they followed the test. This was assembled in the UK, another LCD structure, but it was done in such a hurry that they didn't follow my test procedure, which I said, please test all of the modules before they come to site. Well, it wasn't completed, and they assembled it in a rush and trapped wires. So I was up there soldering, dropped this gas soldering iron, and it just went straight down 51 feet and bam on the floor. I mean, it didn't explode, but I had to buy Mike a new iron. But that's definitely a result of... And I'll be honest, I had not had any proper rigging training. I was in there with another rigger. Right, they were just like, put on the harness. I mean, it was a seated harness.
We'll tie you to something.
It was kind of like, just go for it. And I was shaking. I was really shaking. Michael, I would be too. Michael tell you, he was on site. Mike was up and down in there like a rabbit up a drain, or rat up a drain pipe rather. But I was, I struggled. It was quite funny, but we got the job done.
I don't do heights. I don't do heights personally.
And it was swaying around in the wind. Nah, I'm not doing that again.
Nope.
And it was claustrophobic. It was only like sort of 4 feet wide inside. Another bad memory.
So I'm interested. I'm always interested. So I've talked to Mike about a lot of his projects, and he came and gave a talk at one of my events out in San Francisco as well, and he was talking about some cool projects. But the thing that always interests me is, so like you mentioned the LCD manufacturer. So like those things don't come with drivers already on them. The manufacturers are just basically giving you raw elements. I always assume that like for all this stuff, it's like, oh, well, there'd be drivers attached. You know what I mean? Like, because you can buy small versions with stuff already integrated, but that's not really the case for your stuff, huh?
Well, I mean, this particular example, I guess the most similar thing, or the object that it's most similar to was an automatic welding mask. And because it's just a single cell, it's really not that tough to drive. You provide a symmetrical AC waveform of a few volts, say 5 volts peak to peak, 5 volts amplitude, and that's enough to drive it and make it go opaque. And if you remove the voltage, drive it back to zero, it drains the charge out of the inherent capacitance, and it goes back to being clear, or vice versa, depending on the polarization.
Oh, so this is shutter glass stuff. This is the one that was in there.
Yeah. So it was sort of 2,500 shutters, but with ink inside each of the panels. So that was actually we brokered that through a company in Ohio, I think. LXD.
Kent Displays or something like
LXD.
That? Oh.
So I think LXD might have moved out of Ohio, or our contact there might have done. But the toss-up was either Kent Displays or LXD. And I know that they farmed the manufacturer to China, but they were great in developing stuff. And I certainly learned... Yeah. So we had to colour these shutters in green and yellow, which were the colours of the Oregon Ducks. Go Ducks.
And
I initially just peeled off the polarizer off the back of this LCD sample that we'd been given and put a lighting gel in there. And that wasn't good enough. It just kind of broke it because the lighting gel was depolarizing the light. And so you have to have a non-depolarizing pigment in there. And I sort of said, oh, well, can we get hold of some? And 3M do it, and they do everything. But you have to buy, like, an insane amount.
Right, like rolls and rolls and rolls of it kind of thing, uncut.
It actually comes as a liquid, I think, and you pour it in during the...
really?
Yeah.
Wow.
I don't know the details of the manufacturer. That's what LXD did for us. But they were brilliant with it. And it was really interesting to sort of see and get involved with. But, yeah, I did that for quite a while. I worked on some stuff for the Olympics. I got to go to some great parties. Wow. I got to do some cool events and I was on some TV sets, sort of hiding out of the way in the sort of shadows whilst television adverts and things were being shot. And it was...
So you're like the man behind the curtain kind of thing?
Yeah, about 4 layers down. The man crying by the curtain would frequently be me.
The soldering iron and the salty tears.
Exactly. I still remember a particular film director who was shooting an ident for Channel 4, one of the main terrestrial channels in the United Kingdom, who had got himself a laser pointer to point out parts that were not functioning correctly in this thing that we'd thrown together in an inordinately short amount of time and started filming at 5 a.m. And I was exhausted, and he was just going, here, this one. And I was fixing one. He goes, hurry up. And I turn around and I go, I'm sorry, fella, I've got 2 speeds. I've got how fast I was going and really fucking slow. So it's up to you. It's up to you. You can't make me go faster because it will not work. So you're going to have to calm down. I understand this is your thing, but you can't just start getting lippy. And he went off and got a coffee. And I got some space to work, but I don't think I dealt with that as best as I could, but that's what 5 a.m. me was feeling. I was not impressed.
Right.
So yeah, I'm not always great at client relations. I'm getting better.
Yeah.
I'm getting better, but
yeah. So okay, so you're not doing this anymore. Surprising that sounds stressful. But what have you been doing in the meantime?
So I finished up there, and I kind of put my foot on one boat while I was still there. So I got a call from a friend, again from the Royal College of Art, from the year ahead of me. And he said, look, I've got this project with a bicycle generator to charge mobile telephones in Uganda. Do you want to come on board? And I thought, I don't know about this. Magnetic power generation, low voltage, not even high voltage, mobile phones, hot countries. I don't know if this sounds like a good idea, but again, because I'm one of those people who likes to take on silly challenges, I went, all right, and well, come on then, let's give it a go. He goes, all right, we've got a bit of funding. We're going to be in the Innovation RCA incubator. I need you, to come and take a look, and then we'll sign some contracts, and we're going to try and make bicycle generators to charge phones. So I arrived on my first day there, having said goodbye to everybody at Jackson Brew Studio, although more kind of au revoir because we still hang out a lot. But I arrived there, and they had this bicycle on a kind of frame and a motor strapped to it, a DC permanent magnet motor. And they were saying, we just want to ride this, charge a battery, and we'll sell it. And people will ride the bike from town to town, and they'll charge the person who's riding the bike will stop and offer people charges and put it up on this stand, and then it'll spin the wheel to generate power. And I said, okay, well, we'll see what we can do in terms of power and a number of phones that we could charge and how much we'll be able to sell it for. And it was pretty obvious fairly quickly that it was going to be a tough ask. For one thing, for maximum power transfer, you're looking at 50% rate to get, if you do impedance matching, you're talking about 50% efficiency transfer electrically. So you were potentially throwing away a lot if you wanted to do impedance matching.
Uh-huh.
You were also talking about quite a lot of pedaling to generate enough power to charge up a battery to charge enough phones to really make a business. The charge to it costs almost no matter where you go in the world. If you're having to pay charge by charge, whether you're in India or Uganda or Kenya, and you're having to pay to charge your mobile telephone, it costs about 10 pence roughly. So I guess I don't know what the conversion to dollars would be since we decided that we're leaving the European Union.
Oh yeah, you're our first UK guest since that's happened. Huh?
That's like a 1 cent now, right? I don't think it even registers.
10 pence would be, I think, like 70 cents.
So,
7 cents.
7
Sorry,
cents.
7 cents, right.
Something in that region. Anyway, I've forgotten where we are with that. But you need to charge quite a number of phones in order to make a day's wage. So a day's wage there, you can live reasonably for about £2. So you need to charge at least 20 phones with no costs. Well, actually, that's a lot of peddling in very hot equatorial climate.
Right. Right. I think, people always lose that too. They're like, oh, well, it's just a phone. Like, it seems like, but like, no, like if you look at the power that you need to actually fill that thing, like the capacities are pretty significant, right? I mean, like it's in watt hours, right? I mean, it's like, that's what you need to fill it up with is energy.
And you can, it's exactly that. You do the energy. This is where the concept of energy is fantastic, right? The idea that you can equate mechanical stuff with electrical stuff and then put an efficiency factor in between the two.
Transfer ratio, yeah.
Exactly. I mean, and just to do some modelling with that, it's very powerful. So we were looking at that.
It's really good, actually. This is. I'm sure Dave, if he were listening, he's not listening because he never listens. But he's laid up right now too with his knee.
Yeah,
but like it's like the solar roadways type stuff, right? I mean, it's just like it doesn't quite compute unless you have a super high transfer ratio, and most of the time you won't. So.
Exactly, and that's what we were saying. If you're trying to do peak power transfer, then you're talking about 50% efficiency. If you're trying, you can do lower power transfer, but then you're talking about longer transfer time. So it didn't work out. But what we did work out was that solar panels are not particularly costly to purchase, but that there are a lot of failed solar panel projects out there because they are either a race to the bottom or the charge or the cost to actually buy them with the very high interest rates that you get with microfinance in places like Uganda and India is prohibitive. So the finance, the interest tends to be very high because a lot of people commit to the idea of having something and they commit to what the payment should be, but they default on the payments, and then that results in equipment having to be recovered, which is a costly process. So that gets passed on in the interest.
Gotcha.
And so what we got to was, well, what if you had a solar panel and we give them to people to run on our behalf and we do a profit share with them? So we provide the equipment to trusted people, and this is a model that works for finance. So there are companies who will provide local banking services, giving hundreds of dollars in some case into local banking operators, and a kind of card that looks a little bit like the chip and pin device that you get in a restaurant when you pay the bill.
Yep. And
they will manage accounts for people and allow them to pay into an account and pay out from it without them having to travel to a central, more urban location. Because a lot of the people who I think I'm skating over a lot of the context here, but a lot of the people who have mobile telephones, let's take Uganda as an example, will be farmers growing crops like coffee or perhaps vanilla or cocoa or something like that, and selling that seasonally. So they spend a lot of the year growing the coffee in their plot of land, or growing bananas or matoke or anything else. And then they, especially with coffee, which I think you get normally 2 harvests a year, you'll get a big lump of money in one go.
Yep.
And you'll be super rich, but it's very hard to then keep hold of that money and manage it. I mean, if I paid you twice a year, right, for your job, it is harder to manage money that way.
Of course, right. You have to do projections, and it's probably formally all cash and stuff too, right?
Exactly. And also, you're talking about doing projections for people who may not even have high school education.
Yeah.
So the understanding of just taking, this is the amount of money, if I divide that by the number of days in half a year, that's how much I can spend a day.
Yep.
That's a difficult thing to teach people. And there are whole charities and NGOs who teach these kinds of skills to people there.
Yeah.
But a lot of these people will have mobile telephones because it allows them to do very simple market trading. If you think about the shots of trading floors that you get where you've got people on telephones shouting, buy, sell, what's the price of oil here and there, and blah, blah, blah.
Commodity stuff, yep.
Well, it's the same thing. If you've got bananas or you've got coffee to sell today, and you know that you can sell it in 2 places, you can go let's say you can go down the road to Jinja into town, or you can go up the road into Mbale, which are two towns on a road that runs from sort of Entebbe in Uganda out to Kenya. And if you're between the two, you call up both of them and one says, well, I'll pay you this much, and the other one says, I'll pay you a little more, then you know which way you're going. And it's a very valuable way. It's also a way of staying in touch. It's a way of keeping secure. It's a way of maintaining health amongst families. So if you know somebody is sick, then you can go and respond.
Yeah, isn't it also, aren't they starting to do like micropayments through mobiles as well?
There's a lot of that, yeah. So schemes like M-Pesa and MTN Mobile Money, there are different schemes depending on the mobile telephone network, the mobile network provider in that country.
Right.
So yeah, it's a way of sending money between people and of banking as well. So there's huge benefit to having a mobile telephone. If you think that you're in a place where there is no functional postal service outside of the post box in the post office in major towns.
Yeah,
it's very difficult to transport things. Everything goes dark at night pretty much. And it's a long distance. If I said to you, okay, you can charge your mobile phone, but you've got to travel for an hour and a half. So what's an hour and a half from Cleveland?
Erie, Pennsylvania.
So you can only charge your phone in Erie, Pennsylvania.
Right.
Let's play that game, right? Yeah. That starts to get quite annoying, and I bet you wouldn't charge your phone every day.
And I also bet that I wouldn't be able to drive my car there. It would probably be like taking a bus or something, some slightly...
You'd likely be either getting a lift on the back of a motorcycle or getting the kind of local taxi buses, which sort of wait until they're full and then go between places. And it costs you money to do so.
Right.
So actually convenience is really important as well. Convenience is you can put a dollar value on it, or in Uganda, a shilling value on it. So we worked out that if we could do this, we could trust people, we could get them to run these solar panels and these systems and charge out there. But how are we going to pay? Well, there's a big story to this, but integrating mobile money payments is fine if you're going to go for one mobile network operator, but aggregating across lots of them, much like the problems that we have in the IoT with communication between standards being difficult, you have communications with standards being difficult. So there are services.
And you have to do it. You can't just like integrate 20 SIMs because you have to also maintain that over time and firmware updates and all that other crap that you have to do in any kind of network like that, right?
But also, it's the kind of thing where they're like, it's a bit like talking to chip vendors. So you're going to do 250,000 transactions this month, right? No. Yeah. I might do 10 initially because I'm trying it with one person who we're trusting.
Right.
So trying to innovate in a very difficult space. So we then looked at premium SMS. So the way that people vote for, I guess, X Factor or whatever else, or they used to buy ringtones. They still do a lot in Uganda. Problem with premium SMS is that it's very low return. It's meant to be used, or it's generally used, to buy and sell goods that don't have physical delivery. So the profit margin on them can be very high. If it's a digitally reproducible good.
Marginal cost is low, you're saying, from one item to the next, right? You're
quite right, yes. Yeah. The marginal cost. So once I have the rights to a Crazy Frog ringtone, I can sell it as many times as I like within reason, paying the license fee or whatever as I go. So the fact that I only get 50% perhaps return, and if you're talking about aggregating across all network providers in Uganda, last time I looked at a quote on that, the return was 30% and you got paid 6 months in arrears.
Oh, wow.
And that was a genuine quote and the best quote that we got. So there have been challenges there.
Cash flow issues.
There have been challenges, and that's something that the team has now worked on and integrated much better. We spent a lot of the time actually mocking it up by getting people to send multiple normal texts. So we weren't actually looking for revenue. We just had to make it cost them the right amount to adjust the market elasticity point to a point where it was representative of the kind of demand that we might actually experience.
Yeah.
So that was amazing. I joined them. I did a couple... How many trips did we do? I did one trip to Uganda, 3 weeks out there, soldering and having soldering interrupted by the generator going out, spending my evenings gambling with other people who I could find who were willing to bet with me on which lizard would catch particular flies in the hotel lobby.
Nice.
Also... Staying in a hotel where the hotel Wi-Fi what was the name of the hotel? It will return to me. The Mount Elgon Hotel in Mbale, which I can highly recommend if you ever find yourself in Mbale. It is the number 2 hotel in Mbale, I think, on TripAdvisor. Out of 2 hotels that are on TripAdvisor, there are many smaller establishments. It will always be my favourite because the staff there were just so very accommodating. But they had mobile internet there. So again, we're talking about a place where the proliferation of telephone lines is very minimal.
Right,
pretty much all of the internet, as I understand it, goes through actually one of the hotels in Entebbe. So the main fibre feed, I think this is what one of the telecom engineers was telling me. I think it goes through the Hilton or something. I might be wrong on the details. But it's not widespread, and this is another reason why mobile telephones are very...
it's the only infrastructure, right? That is what it is. I mean, that's actually why when you read about mobile speeds in a lot of countries, it almost always outpaces the wired stuff because
it's much easier
to drop a tower than dropping that fiber, right?
Yeah, you drop a tower, nobody's going to steal. You only have to have the tower. You don't have to run lots of copper that might be valuable or that people might try and hook onto or whatever else. And you just have to pay for diesel or kerosene to run the generator and for somebody to guard it. And that's a relatively cheap thing to do, right?
Yep.
But so this hotel we're staying at, and we're like, okay, what's the Wi-Fi? I mean, the Wi-Fi was abysmal. And the reason it was abysmal is because it was a 3G dongle and a router.
Yep.
And that was it.
Yep.
In the hotel lobby. And sometimes you could get a bit of Wi-Fi in the rooms if it was the right phase of the moon or whatever else. And as Dave would say, if your tongue was at the right angle.
Right, of course.
So every couple of days, we would try and log on to the internet and it would just come up with the orange Uganda splash screen saying, please top up. And you're like, oh, man, this is, can we put a bit of money in the meter over here?
Is there satellite internet? I need a data sheet.
Wow. I mean, data sheets were out of it. It was very small amounts of email and making sure that we were well prepared. We had a full medical kit and everything.
Yeah.
Because you just need to be ready, and you could be a good drive from a hospital. So if you get bitten, you need to be ready. But and in the end, we started chatting with the hotel staff. I mean, we were there for 3 weeks. We saw the Hasidic Jews who were there to do missionary work come and go. We saw the American field doctors who were doing some amazing cataract surgery out in the bush there come and go. But we got friendly with the hotel staff and they showed us the router. And it had a connection for an antenna, something like a reverse SMA or something like that, or SMB. And we had an aerial with us, and we plugged in the aerial, and we were flavour of the month. Suddenly, you could get much better internet and everything else. And I think they were rather upset when we took it with us out. When we took it with us into the field. I have a feeling that we left the actual antenna behind when we went back to the UK.
Yeah.
But it was an amazing adventure, and India was equally simultaneously frightening and absolutely marvellous. I mean, I remember sitting in a market sort of area of town.
Which part of India?
Absolutely strewn. So this is in Bangalore, or Bengaluru, as it now is. Just outside of cricket season, which was infuriating for me because I really wanted to go and see the Royal Challengers Bangalore in the IPL.
Yeah, they got some good cricket out there. Yeah.
They are a nation of cricketers. But we were in the I think it was just off the MG Road in which is Mahatma Gandhi Road, MG Road in Bangalore. There's this kind of big market area where you can buy anything. I mean, we were buying micro SD cards at very, very unusual prices, and with really sort of like that you could buy anything. You just had to go down some very dark and frightening alleys through sort of open sewerage and all sorts
hard
of
pass.
Yeah, dude, it was real, but also really, really interesting to see that these are just dudes and ladies getting on with their life. Right, this is life.
Yeah,
just cracking on. And, it's just like everybody else. And so we were there, and we needed to we got these units out into India, and we were doing integration there, and the handles on the units were snapping because of the load. It wasn't quite correctly made. So we thought, oh my God, what are we going to do? We're out in India. It's not like we're going to be able to go and get some more precision plastic parts done. So we just drew up a couple of plates of steel that we wanted cut and went to the market. And it took, I would say, 3 or 4 hours. That might be an exaggeration, but it felt like 3 or 4 hours sat about waiting for people to talk about steel and to cut some steel. We ended up getting the steel cut, and then we had to take it to another person to get it drilled. And sat down like a blind alley with my friend Damon, gently worrying about whether my life was in danger. Damon's travelled more widely than I have, and was quite calm, at least on the outside. But we were sat there waiting to get these things drilled, and then in the middle of the drilling, the call to prayer came. And we were in. It was. Hang on a minute. No, it would have been. Well, it was the Muslim guy who we were working with had to go to temple. Which temple I can't remember, because obviously you have very many for the various deities, but he had to go. And so he said to us, "Can you watch the shop?" And I said, "Well, I guess we have a choice. You're sort of halfway through a job for us. Is anybody going to come?" Not really. A couple of kids sort of hung around, and we sat in this alley waiting for the dude to come back, and he did, and he finished the job, did a great job, and we bolted these reinforcements onto the units, and I imagine that some of them are still out there, all set up like that. It was, great experiences, but something that I've now again moved on from, because we got it to the point where we had working proof of concept units, but the crunch was really boots on the ground. So we needed people
integration testing, all that stuff, right?
And to be running it day to day, even beyond integration testing. How do you, since the business model that we had would involve an awful lot of agents and basically having a business that was largely in either India, Uganda, or wherever you're deploying the unit, not in London. It's not about having lots of middle class European white dudes sitting about talking about how wonderful they are. It's about people providing a service where it's required. So you actually don't need middle class European white dudes, but what you did need was to come in and take the business development, not in terms of going out and talking to VCs, but the business development in terms of making the business work in the countries we were working in, to come along. And so I said, look, I really think that's where we should be putting my wage money. We should not employ me, and we should have somebody come in and do that. And there was a little bit of back and forth. It wasn't a universally popular decision at the time, but it wasn't ever... it wasn't like I was done with it, or like I was unhappy with it, or I wanted to leave. Yeah,
you weren't walking away, right?
It was about trying to make sure
the cause.
The company, flourish. And so I left. And the whole time, I said I'd been doing sort of freelance work, very similar to the stuff that I'd done at Jason Brew's studio. But the whole while I've been doing that, I've been doing bits and specifically bits for Bear Conductive, which is a company who do capacitive sensing and making otherwise dull and dumb surfaces into interesting and intelligent surfaces. It's really quite
right. Before we get into that, I have one or two more questions about the solar thing.
Oh yeah, sure.
So what was the level of integration? I mean, were you doing like the MPPT type stuff as well, or was it kind of off the shelf integration type stuff?
So with the initial units, we were actually using an MPPT dev board from NXP which was an ARM Cortex M3, I think, at the time, which shows you how long ago it was, because nobody buys and sells M3s anymore. But that chip actually got discontinued before we could integrate it into anything. And the main part of the design that needed work was the power distribution. So we were using USB ports for power distribution as a sort of as something approaching a standard, although we're not talking about plugging in both Android and iPhone here. We're talking about strange... I don't imagine you've ever seen a Saga telephone, but they're very popular in Uganda, or some other promotional phones that are given away or produced at low cost in India. So you have to be able to plug into a wide variety of feature phone sockets, and we had these bizarre... We called them octopus cables that sort of had every possible connector on the end.
But at the end of the day, it was mostly 5 volts of various current draws, and then the weird ending connectors.
Yeah, exactly. The only thing that doesn't... The very old Nokias don't do the 5 volt, but we ended up... I mean, you also have to shoot a little bit for the future, and they are less common than you'd think.
The EU standardization kind of really pushed that stuff along, which I'm grateful for, because that really changed a lot of things for mobiles.
Yeah, it's true. But yeah, so a lot of the custom work that I did was, so there was some interconnect stuff in there. There was power distribution and management and switching. And then having a central, so we actually used a BeagleBone Black initially, although this is all stuff that's getting more integrated now. And Damon did a lot of the integration to allow us to hook up to the cellular network and integrate with various payment providers and do tracking and in the field updates and logging to get data back so that we could be back in London saying, to potential investors, look, this is actually happening. We're getting 100 charges a day in some of these locations. That's profit for our, that's a good business for our agent, and that's profit for us because we take whatever percentage of the income. But the MPPT, we actually ended up using, I suppose I can plug them on now, but Rock Solid Solar, who are an Australian solar MPPT company. I don't know, maybe Dave has. I can't remember quite from where they are, but we used a module from them for a while, and now it's got to the point where the proof of concepts are out there and the business is being developed and the volumes of units are no longer in the tens or so on, because also it's about failing fast. So we weren't particularly bothered. I'm sure I can do the MPPT, but proving that I can do MPPT isn't worth the time in the field finding out how people use it. With the studying at the RCA wasn't just posing or trying to get into parties or getting good connections for later in life. It's about understanding the way that you're always selling a relationship. Even when I was working at a high voltage place, we weren't selling high voltage power supplies. We were selling the relationship that you can believe in us and we will deliver 8 ppm per hour drift, right? Which is crazy. But on a high voltage power supply, but we will deliver it, and we will deliver, the switching speeds that you need for your mass spectrometer because you trust us. Right. So it's about understanding
it sounds like you were doing, the way you were talking about the problem too. I mean, you were looking at it holistically. You weren't necessarily just approaching. I mean, you had the EE background, but you were looking at, actual field tests, understanding that the bike wouldn't quite work, trying to find these other methods. Well, that's a holistic product design versus just the one piece.
Yeah, and so, Phil, the guy whose idea the company was, the bike was his idea. It was his pet idea, and it's a beautiful idea, but we had to explain to him that we didn't think it was long-term viable. And that's not an easy thing, to take somebody who's brought you on board, been very generous in employing you, and said, can you make my idea work? And turning around to them after a relatively short amount of time and saying, not we don't like your idea, but we don't think that your idea is best for the company. That's a difficult initial conversation to have. I mean, Phil was incredibly understanding about the whole thing, but it does,
Yeah. Well, I know someone that worked at a not quite the same kind of, it was, a battery charging type of scenario, but I had two friends who worked there, and they didn't quite do that due diligence. They weren't part of the due diligence at the beginning. They were just implementing, and they did the best they could. But at the end of the day, it's like it was like physically impossible to deliver that stuff, and that's where and it basically ended up affecting the company in the end, that it couldn't deliver on what they said they could. So all the investment money that went into it was wasted.
Well, this is the thing. The road to hell is strewn with good intentions, and you do sometimes have to be. You have to know. What is it Kenny Rogers would say? You have to know when to hold them, know when to fold them, know when to walk away, and know when to run. Right?
How can you possibly say you're from the UK if you it's such a critical part of U.S. culture?
Kenny Rogers was big in the car. The guy Elias who drove us around Uganda, who looked after us and fixed stuff for us. He loved Kenny Rogers and the Christian worship CD. He also had a bit of Dolly Parton in there. He was Muslim, but he loved the Christian worship songs, and he was happy. There was no reconciliation to be done here. He was like, I like them. They're good songs. So I was like, okay, that's cool.
All right, well, you're driving. You get to choose, I guess.
Dude, you totally got to choose. It was those 3 CDs for 3 weeks. Boy, howdy. Oh, so, I heard a lot of The Gambler by Kenny. And I still love it, which I guess goes to show that Kenny Rogers had good things to say.
There you go. Yep, exactly.
But yeah.
Okay, so Bear Conductive. So now you said you were still consulting, and what is Bear Conductive?
So Bear Conductive, I don't know if I have the company line right. I'm never very good at this kind of thing. But from my point of view, we take passive sensing and use it to generate data in a meaningful way from unexpected places. So the nice thing about cap sensing is that it's relatively cheap to make relatively big things. You can then sense things in either a cheap way or in a way that's integrated so that you don't make people feel like they're being spied upon. It's also inherently anonymous. It's not like a camera where you can identify people particularly from it. So the company started, however, as a student project. So we're going right back to the RCA again, which is this terrible cult I am part of and will never escape. Please help me.
That's good. It sounds like it was networking,
it's fantastic,
for the rest of your life,
but you have to be careful of not trapping yourself in an echo chamber. It's very easy to all sit around coming up with ideas and deciding that they're a marvellous and good idea, but you do, again, have to be open to people from outside. One of the things we work hard at Bear Conductive is employing people who haven't been to the RCA to make sure that we don't develop a monoculture. But
that's good.
So it started, Matt Johnson is a good friend of mine from the RCA. So you've got Matt Johnson, Bibi Nelson, Isabel Lizardi and Becky Pilditch. So those four were at the RCA, same course as me, same year, and our course has 2 end-of-year outcomes. At the end of the first, 2 outcomes in your final year. Halfway through the year, you complete a group project, and then you do a solo project to the end. And their group project was a non-toxic, carbon-based, carbon and water-based electrically conductive paint. And the idea originally was to investigate electronics on and near the body. Now, I have to be very clear and say, before anybody gets the wrong idea, the paint is that we sell now is definitely not approved for skin use, and we wouldn't advise that anybody did it. It is non-toxic. There is very little likely to... I mean, I've eaten the paint, and it's not killed me. But it might have turned you a little weirder, but that's just life. The baseline was very difficult to detect before, though, so it's hard to tell. It's all about deltas with stuff like that.
It's all about deltas. That's right. But precision versus accuracy.
Exactly. I think both are shot on this particular model. But so they had this idea of this electric conductive paint, and they did some really beautiful demonstrations. And they came from this conceptual idea of what can they do, on and near the body. It wasn't how do we make the most conductive paint that's going, right? There are loads of conductive paints out there, and inks and carbon nanotube this and silver loaded and copper loaded and graphite loaded, all these things.
Right. So they specifically weren't trying to do like the conductive pens where you're like hooking things together one point to another, that kind of thing, right?
Although they did do sampling circuits that way, I think they very quickly realised that its use as a sensor was the most interesting thing about it. Or opened up some of the most interesting applications. But the initial projects, they started, so they got some seed funding, and when I moved back up to London to go to Jason Brew's studio, my friend Matt was looking for a place to live, and we moved into a converted warehouse in Manor House in London, which is like a crazy warehouse party scene. I have to say, excuse me, I am done with warehouse parties for the rest of my life. My God, when they start on Thursday in the morning and run through till the following Wednesday, and nobody shuts up. I mean, solidly.
That's not my style.
We're talking aggressive dubstep drum and bass. There was a big summer of I think they called it MCAT. Was it MCAT the name of the drug? Which was what's the heroin substitute? It's not that. So it's not methadone.
Methadone. Jesus.
Mephedrone. Was this drug. Anyway, there was loads of that going on that summer. It was, to call it messy is beyond belief. I did meet my girlfriend whilst living there at one of those parties, but we have both since moved on, and I'm still with her. So good things can happen in strange places.
Right, of course.
But Matt and I moved into this converted warehouse, and there's a huge space. And so Bear Conductive started. I would go to work at Jason Brew's studio, and they would come to work in my flat. And then we would...
Oh, weird.
Yeah, we would swap back at the end of the day. And I still remember coming home one day to find that my house was entirely black because they'd put a mixer and had some sort of incident with a lot of carbon black, which had gone all over the inside of the flat. And I tell you what, when I left that flat, I was still cleaning it down, and it goes everywhere. So, again, who knows what troubles I have.
Science is messy. Science is messy, man.
Science is definitely messy. But what you were talking about, what their aims were. I think the nice thing is that at the very beginning, there was a limited understanding on their part about the existence of conductive paints and inks. They had vague ideas that you could buy like a silver paint pen from Maplin to fix things, but not of the breadth of the market or prior motivations and industry sectors that use them, right?
Mm-hmm. Yeah.
And the naivety, if you like, in their understanding of what had gone before, but their solid understanding of design thinking and of process and of rigour and of an experimental approach led them to some really interesting areas. So they started making this paint, and they got to a point where they made some kits where it was point to point, like you say, but basically kind of a lithium battery, a primary lithium cell, and some of the paint and a flashing lead, right? And they made that into some beautiful cards. So they contextualize it in a way that taught kids or people who were interested in playing with the idea of conductive paint about it. Another really nice thing is it's super cheap to make, so you can screen print it and not worry about the fact that, if you take other, say, silver-loaded paints or inks, they're not really silkscreen compatible because they're very thin with the solvent.
Right.
And they're not cheap enough that you can dump, a tablespoon of it into a screen and flood it. So they started to play around with these things, and they came to me and they said, we've done some things with this Arduino and kind of CapSense library. What do you think? We kind of want to start to play with it and maybe do a version of a board with it, maybe that makes audio, so you can kind of paint a poster and touch it and then it plays audio. And so I started to look at some of the examples, and actually I did a lot of the research based on modules that were available at places like Adafruit and SparkFun, purely because I, in my freelancing, had gone from, so if you remember back when I said I was talking about microchip controllers and assembly coding, for me, the power in when I was doing development work for clients of using the Arduino platform is that for the vast majority of challenges I was being thrown, there was enough horsepower there, and it meant that I could hand over something that if they then wanted to change in the future, I didn't have to be part of that. Right, I could hand over something where they could find huge numbers of other people who could then work with it. It was a free tool chain. You could get the most professional C++ embedded programmer in the world, or you could get somebody who'd come through a design route, and it gave my clients the ownership. So I was like, look, we should maybe do this with Arduino. And then if I pick and choose from modules and so on that are out there, then we know that there's a reasonable established market. You know that the availability of those parts is going to be reasonable, and that there will be libraries that people will be able to access to take control of it themselves. So if they want to write, their own bit for it, or they want to use somebody else's library for that part, they have that choice. And that became the touchboard, which was the first circuit board,
which is that's the board that some people might have seen, right? It's got like it's not castellated edges, but it's like touch points on the edges that you actually hook wires into.
Yeah,
right?
It's got 12 edge-plated electrodes along the top. It's got an onboard MP3 player. It's got an Atmega 32E4, so it's like the old retired Arduino Leonardo. You've got a micro SD card, lithium polymer charging circuit on there, so you can have a lithium polymer cell. You can power it from the cell. You can recharge it via USB. You've got audio out, and you can do things like USB MIDI. It's got onboard MIDI synthesis. Actually, for me, it's now if I'm going to drop an Arduino into things, I often use it, partially because I know that it's reasonably well designed, I hope, but also having the micro SD card already on there is really useful for anything where you're doing data logging. So I actually use it as a logger a lot. So we kickstarted that, and I think at the point where we kickstarted it, it was the most successful Kickstarter in the UK up to that point. £112,000. I think I'm getting all the figures wrong, no doubt. Matt will be spitting feathers when I see him. When he hears this, but I think it was something like that.
It's okay.
So
it's just numbers, man. It's just numbers.
Well, it doesn't make it. Look, I didn't join the company in order to. I joined the company because when I was freelancing and when I moved on from Buffalo, they were just my favourite freelance client, and they were friends, and
it's exciting stuff and probably good good users of the product, stuff like that. Right? Interesting.
I find it really interesting. So we made this thing largely for makers and got it out there through Kickstarter, but we knew that we had in understanding the capacitive sensing side of things. So I actually ended up writing a whole new library for the MPR 121, which is the CapSense chip on there, where I really stripped down and tried to really understand what was going on. Not just a parallel plate capacitor thing, but how do you optimize sensing? How do you give people the kind of Apple out-of-the-box experience whilst leaving the lid open enough that people can go in and get right into registers if they want to? And I wrote it for what we wanted to do. And in fact, off the Kickstarter, we got contacted by a number of potential industrial clients saying, whoa, you can sense over distance with paper. And we're like, oh, I kind of hadn't thought about it that way. But what we had shown them in our Kickstarter video was very cheap sensors, right? Screen printed paper with cheap paint, electric paint, and a board that we were selling for whatever it was on the Kickstarter. And we'd shown it sensing over distance and sensing through tables and sensing through glass. And I think that the engagement that we got there brought us on and brought us into the interest of a number of industrial clients. And that's where we're now doing a lot more of our R&D. So we are bringing out out another consumer face product in, I think, September, maybe early September, I think, which is very similar to the touch board, but for the Raspberry Pi. And it's specifically designed around the Pi Zero. So one of the things that a lot of our customers want to do is to have polyphonic MP3 playback. But this also, more importantly, gives us a bridge between the capacitive sensing and things like, well, an operating system fundamentally. So the internet, all of that kind of management.
Linux-based, exactly.
But also a wider variety of languages. So you're not stuck with Arduino. So we have a C++ library, we have a Python library, we have a Node library in the works. So some JavaScript, which I know you're a fan of.
Well, yeah, of course. But I mean, like honestly, these days for a lot of this stuff, it's especially if you guys are basically bringing people into the you guys are recruiting more potential amp hour listeners, and that's fine with me, honestly. Like it's bringing people in that are software and want to get hands on the real world. So it actually, I think it makes a lot of sense for this kind of stuff.
Yeah. And
question about that though is how do you get a Raspberry Pi Zero? Because those are kind of purple screws right now.
There is I like the expression purple screws. I always say unicorn poop or hen's teeth. But purple screws.
Yeah, I've heard hen's teeth too. Yeah, unicorn poop. I might have to use that.
Yeah,
like that.
It's tough to find.
Not if you watch that Squatty Potty video. Have you seen that one?
I have not. That sounds that sounds potentially horrendous. Is it going to change how I feel about things? I don't know.
No, it's actually it's very catchy. As surprising as all that sentence was, it was very catchy.
I'm writing down the words squatty and potty next to each other. I didn't expect to do that today. They're good words. They go well together.
Well, a little bit of surrealism in your life.
Why not?
You'll see
a little nonsense now and then is relished by the wisest men. That's what they tell us. I don't know where we got before that.
We were talking about the Raspberry Pi Zero and why you can't get them.
Yes. Well, we were very lucky. So we have good contacts with the people at the Pi Foundation and Raspberry Pi Trading.
It's a British thing again.
Well,
come on, man.
They came to us when they were getting ready to release the Pi Zero, and we talked to them about doing something. We've actually held off releasing a little until the audio on the Pi improved. Which is, I think it's actually now current in the latest version of Raspbian, but it's certainly something that we enable. So we get 15.5-bit audio out now, which is a lot better than the onboard audio used to be. Which is, let's be clear, none of my work, some great work going in by the hard people beavering away at the Pi Foundation or working on the Raspberry Pi Linux side of things.
Yeah.
But they give us a bit of a heads up on some boards. And also, I just keep an eye... again, I don't want to plug too many companies, but there is a website, Where Is My Pi Zero, which aggregates where your Pi Zero may or may not be, in terms of who has stock. But places like Jamie Mann at the Pi Hut, I've bought one off him last week. It's a case of tracking it, and I mean, it is one at a time. I think it might be tougher in the States because I think you've only got Adafruit reselling over there, right?
I've heard that you can get them at Micro Center. That's what someone told me.
Oh, that might be right. Micro Center are a great company. I love them.
I do too. They are basically they've turned themselves into like quasi Radio Shack without the components. Like at least for dev boards and stuff, you can get a lot of stuff there, which is really nice.
I was lucky enough. I think it was the head honcho at Micro Center. I met him at Maker Faire in New York a couple of years ago, and he was just a straight up brilliant dude. Really, really nice. And he had a lady who worked with them who I think she'd started working in the shop and she'd worked her way up quite high in the company. It just seemed like really reasonable people. I know there's a lot of people who are wonderfully reasonable in the kind of maker community, but I was really struck by the Micro Center people. Really nice. Yeah. But yeah, so that's how we got our hands on the Raspberry Pi Zero. But this add-on will work with other Raspberry Pis as well. But that's one area. So we are doing that, but we're doing some fairly serious R&D now. So I enjoy kind of wrestling with physics and trying to beat it into submission. And I'm getting the opportunity to do that a lot. I'm doing a lot now of straight up field design. So it goes right back to stuff I learned doing the high voltage stuff. Things like how do you do field confinement? How do you make one-sided capacitive sensors? How do you make capacitive sensing work over a long distance? You know, if you're going to actually have, rather than putting localized stuff and having digital data, how do you confine the field over coax and things like this without losing sensitivity or loading the lines too greatly? How do you make all of that compatible with EMC regulations? Why is any of this important? What do we really want to sense? And we are working, sadly, with companies that I cannot mention, but I'm looking forward to, in the next couple of years, actually releasing products with these companies and saying, look, this is what we're doing at one end of things, but we're still releasing these open source and open source software and open source hardware products for the maker community as well, because we get such interesting stuff back off them. I mean, another great thing, one of my favorite things with the Paint is it allows you to iterate and create custom interfaces really quickly. So if you want to just say, oh, if I lay out buttons like this, does that work? You can screen print it, put it on the touchboard, blob it in. You can be done in 30 minutes, right? And that is a straight up UX prototype. We get people doing things like creating custom musical instruments for people with profound physical disabilities. And you just think, whoa, I am so glad. Like, it's totally worth putting the effort in and making that board and supporting it if it gives people the opportunity to do that. We get people doing beautiful artworks. We get the people making lovely posters with their kids. Just spending a weekend drawing a beautiful poster out in the Paint and then connecting it up and putting, I don't know, farmyard sounds on. We get kids doing school projects with it.
It's just like not automating the world. It's kind of livening up 2D things, right?
Yeah, exactly. And you can do it in 3 dimensions as well. I mean, that's where we're starting to do a lot of this R&D is on 3-dimensional surfaces and field containment within volumes. So looking at stuff passing through volumes, and it's great. It's great fun.
A spherical cow extruding milk in all directions, or whatever that is.
I don't know. That sounds like another crazy. Does that go with the squatty potty? I don't know.
No, that's a physics joke somewhere. I forget what it is. Yeah, it's something about a spherical cow. It's like how everything in E&M, in physics E&M, kind of comes back to like a infinite plane or a pure sphere floating in space type of thing.
No, it's true. It's kind of like, I mean, Picasso really took that to town, didn't he? The Cubism type thing, or reductionism to primaries, primitives.
So this chip that you're using, the MPR 121, I've got the data sheet up, and this is a hefty set of registers. I mean, it's 128 registers. Yeah, this is pretty. Yeah, that's crazy. 16-bit registers, is that right?
So you get 10-bit. 8-bit. You get 10-bit readback. I think 10-bit.
10-bit.
Yeah, 10-bit.
2, 3. Okay. Okay. See.
And it's got some incredible filtering on it. It's a really interesting chip, actually. So it's originally a Freescale part. And then there was the whole NXP and Freescale thing happening. And in amongst that, it got completely jettisoned from the company. So I had assurances from Freescale about the longevity. And they jettisoned it. And we went, oh, man, I'm sure we could... Obviously... There are a lot of...
Last time by.
Oh, man. Rochester Electronics, not my favourite company in the world.
Oh.
But
me neither.
We looked at that and we said, okay, look, we can do things differently. We could take the whole touchboard down. We could do it all with integrated touch peripherals, right? That now with the ARM Cortex
a lot of
market,
the micros that have them.
Well, look, they're trying to differentiate between the same core amongst lots of different I mean, soon there'll be no need to differentiate, because after Analog bought Linear today, they'll only be like they'll be the monolith chip company, and that will be it.
You had to bring it up, didn't you?
I'm sorry. Well, I do pay a little attention, and
I was waiting to bitch about that until next week, but sure, yes, we can. Yeah, we should acknowledge the inevitable. My favorite chip company has been absorbed by one of my less. I don't dislike Analog, but
Analog's
I didn't like them as much as Linear.
Are really beautifully designed. I would love to meet the person who does their capacitive sensing dev boards. They have there's a really nice pro move on one of them that I'm working with at the minute, where you have the chip that you're working with, and you have I think it's an LPC processor on the side, and USB connectors and ground planes, and it's all properly done, and the ground wires are stitched appropriately, and it's well designed. It's got square pads on the top of the breakout area so that you can do surface mount, and circular holes underneath so that you don't bridge. It's been well thought through.
Yeah,
and it's got a little.
Yes.
Well,
sure.
It's got a little bit on the side where they've got two chips that are just held on with pads in opposite corners, and those two chips are your samples. So they're just tacked down. And then you can just easily pop them off with a heat gun, so you know where they are when you need them. And that was a really nice touch, I thought.
Oh, that is a nice touch. Okay, I'll give you that.
It might not be enough to sway you, and we'll have to see what happens with Analog and Linear.
I've used a lot of Analog parts. It's just that I didn't like them as much as Linear. And Linear, they've got their quirks too. So.
Well, I really like Linear data sheets. I have to say that they're some of the best.
LT Spice, if they touch LT Spice,
well, I think that the world might end if they touch LT Spice. I've used it for several things.
Well, we've had Mike on the show, Mike Engelhardt, who basically is the maintainer.
And
he's the main trainer.
I missed that
he's the creator too. Oh, if people want to listen, that was a fantastic show. And to Analog's credit, we had Hank Zumblin on. Hank's great. He's one of their lead, Analog's lead application engineers, but yeah.
Well, let's hope that the cream rises to the crop and not the other way around.
I'm sure that'll be fine. I hope.
Yeah, I hope so too. But yes, so we had all these assurances, and they jettisoned it, and they said, this company, Resurgent Electronics, will be taking it on. I was like, Resurgent, Rochester, both start with an R. The price is going to go up 10 times, and they're just going to do end-of-life stuff with it. And we could go another way, and we could use other integrated touch peripherals. But I'll be honest, I've trialed a lot of CapSense chips out there. If you want to make robust interfaces that work no matter what you clip them to and how badly you abuse them, and can do really nice proximity and yet really robust touch, and they just work, and the filtering is all just as you want it to be. The NPR 121's a great IC. But I got in touch with Resurgent are really two guys, I think, with a lot of experience in silicon. And Duke Adapa, their, I guess, CEO, I got in touch with him. He's like, look, we've got no need to put up the prices. We've got no wish to do so. We want to, if we can, we'd like to grow the market for this chip, but we don't need to sell that many to make it a viable product for us. We bought it up. We've got all of the tooling will be exactly the same. We're not changing anything except we're going to mark the top of the chip differently, but it's exactly the same thing. We're just going to run it through foundries, and they straight up just...
Are they going through distribution? Or?
Yeah, so
it looks like
they've got Arrow. It's just Arrow.
Yeah.
So if you see it anywhere else, that's not going to be a reliable long-term source. And as long as you buy a reel at a time, you're fine.
Right, which is what you're doing anyways, I'm sure.
Yeah, we normally have a few reels in stock, and we just do it that way. And I'm sure that everybody else who's on the breakout board side of things, I'm sure Adafruit and SparkFun are doing the same thing and keeping it going. And I think it's a really nice chip for people to learn cap sensing with, because it just, by the time you're questioning the real details of what you can get out of it, you now understand enough that you'll be able to look at other options and make choices yourself. But for me, as an external peripheral, I think it's great.
I've actually never thought of this before, but this is almost like the silver lining of the foundry model, right? Where it's effectively. So you said these two guys have fabless experience, which is great, but effectively it becomes like a what's it called? capital. It's a venture capital move, right, where you buy the IP and you can keep making it because it's on the same process, whatever. And the true silver lining is that there's almost guaranteed in that situation to not be any changes to the underlying silicon, because why would they change something? It's just a cash cow for them.
Exactly.
So us as the users, it's like, all right, as long as the process is still available at some foundry and it's qualified against the other chips, then you almost could have an unlimited supply, which is, of course, big asterisks on that. But
well, I think they
nice.
promised me until 2022. I think. Oh no, 2017. No, hang on. Sorry, go back. 2022.
That's next year.
Yeah. 2017 would be a worry. Sorry, I'm adding and subtracting 5 in my head. No, they said until 2022 and potentially well beyond. So for us, that's great. And
that's probably based on foundry kit changes, right? Where that's probably what the assurance they got from whatever their current
in terms of process and whatever, where they're currently manufacturing. I mean, I don't know too much about IC design, that's for sure, but or manufacture. But they seem, again, like just people who spotted an opportunity and are making it work. So it's all good for us. This is
very interesting. I'll have to look at this. So resurgentsemi.com.
That's it. I think they only pretty much have the MPR 121 and maybe the MPR 03X, which is the lower electrode count version of the IC.
I'm sure maybe there's just a general business for this kind of thing too. It's just kind of being like the shepherds, the warden of the chips.
Yeah, I think anything that stops it being Rochester Electronics sitting on a massive pile and then selling them off at 4 times. I mean, I understand their business model, and I'm sure that they employ a lot of good, hardworking people. But it really hits me.
Too. You know what? We are not the customers for that. It is the military is the customer for that, and aerospace, and that is. So it's fine if that model extends to industrial and maybe commercial like this, which seems like it might. But yeah, I will never and can never pay aerospace or military prices.
No,
so
neither can I. And it seems unlikely with the decisions that I've made in my life that I will ever be wealthy enough to make those kinds of decisions. So it's.
I think that'd just be an irresponsible product decision too, right? Yeah. Why would you do that? It's better. It's your time's better spent redesigning, which I'm sure you're already doing with these things.
Well, we're working with a good chip, with other ICs right now. We're happy with the B2C stuff. We're happy using that. And look, if we get to a point with a B2B project where the volumes are enough, that'll be enough to not guarantee it indefinitely, but certainly to give us enough of the market for Resurgent that we can be a big sort of customer for them, and then they don't have to worry and we don't have to worry. And if we're not in a position to do that, I wouldn't be an engineer worth paying if there wasn't another way I could achieve similar kinds of things, right?
Yeah, any thought to go design your own discrete circuits to do this kind of thing? Or, I mean, obviously it's not worth it, but have you gone down that path at all?
Not so much. I mean, there are lots of, because of what you can do with the integrated peripherals in a lot of the microcontrollers, there's not a lot of gain to be got out of doing it discretely. I mean, you can. It's a lot of the principles actually are very similar to the kind of ramp generators within things like switch mode power supplies. It's just different frequencies, and then your ramp is generally your output current fed ramp, and then you're doing bursting on that and acquisition through sort of integration. But it's not something. Yeah, I can't see there being a motivation for me doing it. I do know that there are companies that have done their own. There's a flooring company based out of somewhere in Finland, I think, that was based on a university project that used, I mean, dear Lord, their bomb. I really hope that they're using something else in the final implementation. There was like a $20 analog multiplier in the design in the academic paper. I was like, whoa, you were way richer at university than I was. A $20 multiplier. Yeah, right. Like
someone got a research grant.
and how? Right. And it had custom magnetics in the output stage to do impedance lowering, I think. It was just like a, you know, when you go to a fireworks show and they have one of every type of fireworks, you get the feeling towards the end they're just trying to cram in another different type of explosion. I feel like that might be what was going on the board. Maybe somebody was proving that they really, really, really deserved a PhD or something, but or maybe it grew that way. I don't know. I mean, you can't say. Sometimes having a circuit where you can actually probe a lot of the intermediary signals and you can adjust almost every aspect that you want gets you to a result, and then you go back and you think, right, now I know what the result is, and I know what the kind of end game is. I can strip out a load of this stuff that's redundant, but it's a bit like when you build any kind of test rig or development rig. You don't build it with an eye on mass manufacturing. When you're making it, you're leaving test points around. The amount of times, if you think about with the level of integration that you've got now, that you just beg that you could get an intermediary signal out of a highly integrated IC, and sometimes you can get them on debug pins and things like that. But I guess if you're building your own circuit, you would be silly not to leave access to the signals that you want to see. So
right, that makes sense. Right, yeah, kind of like internal probing by making everything external, huh?
Yeah, exactly, the old-fashioned way.
Yeah, right.
But yeah,
well, we are at hour 45 in. Maybe we should. I dare ask: is there other stuff? Are you doing other things, man?
I am doing a few other things, but mostly it's just sort of side projects. I like helping people out. So if people email me, I very rarely don't. Mike's always been hugely generous with his time, and I try and pay that forward to other people. I do little bits of freelance here and there, just stuff out of interest. I did some hacking of I wrote a library to interface with an induction cooker earlier in the year for somebody who wanted to make their own design front end for it. That was an interesting challenge, working with really horrible I2C, but it's like I2C that was so far out of spec that I had to write my own kind of
like an interpreter. Almost.
Yeah. So I was using I think it was an open logic sniffer, and then just dumping the data out of that and then running it through my own interpreter. If I tell you that the clock idled low in this particular setup, it was super weird and very clever. I mean, it was allowing the Chinese designed front end board to do button pressing, LED driving through Charlie plexing, and I2C communication, all out of a very small number of pins on a cheap 8-bit micro. So props to them.
Okay, I see.
But it was dirty as all hell. No, I think we better let the listeners. If you have listened this far, I am very impressed. To me, just rambling on in my bedroom talking to you here. But
that's good. This has been a wild ride all the way from high voltage up to capacitive sensing to art panic attacks, I think.
Oh, right? Man, dear Lord, don't. Yeah, I may have to have a sit down.
I don't trigger you.
I'll have a sit down with a beer and try and forget it all in a bit.
I was gonna say, you go play some darts, man. It'll chill you out.
And say hello to the Queen on. No, I don't say hello to the Queen. I did once say hello to Boris Johnson on my way to work. He was cycling. Morning, Boris, I said, and he just went and cycled off.
Yeah, he rode by the meetup when we did the Amp Hour meetup. Someone's like, "Hey, look at that! Yeah, look at that out the window. Boris Johnson's riding his cycling by." And if I would have known now, I would have
just shot
thrown
him.
Something at him.
Yeah. He's a horrendous buffoon. Let's not get into politics. That'll take us all night.
No, of course. But yeah.
Well, it's been great.
Yeah. Well, thanks for coming, and we'd love to have you back sometime. Maybe once Dave's on the mend, we can talk more about CapSense and
anytime.
And especially,
I'd love to.
Yeah, it's been exciting hearing about the future stuff too.
It's great chatting to you. It was great to meet you in Belgrade. And I think the nice thing about the Amp Hour is always the variety of what's on here, and it's nice to be able to contribute into that. And hopefully, I hope Dave's on the mend, and I hope he is listening. Yeah. He should be. He's got convalescing to do.
He won't be. If Dave's listening right now, I can't even say anything, because if I say anything too weird, people will be like, "Dave, did you hear blah 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 on the Amp Hour?" And so it's fine.
Well, I hope he's getting well anyway.
Yeah. Where can people find you online?
So I guess bearconductive.com is where I do my day job. On Twitter, I'm Stefan DZ, STEFANDZ. And I do have a website, but it's so horribly out of date that it's not got much. But
it's not that bad.
That's bycgwtsf.com, which is the worst domain name I ever bought, which stands for "Bet you can't guess what this stands for." .com. I regret the purchase, but I have never come up with a better idea for a domain name. So there you go. That's more fool me.
Well, maybe it's easier to spell than your name too. Maybe that's the reason.
Maybe that's it. Maybe I'm drawn to unpronounceable strings of consonants. That's my kind of thing.
Yeah. Well, thanks for being on. We really appreciate it, and we'll talk to you soon.
Yep. Bye.